I'm a pretty big sci-fi nerd, especially when it comes to space travel adventures. From 2001 Space Odyssey to Project Hail Mary, I just like big ships, navigating unique physics, and the perils of the void. I remember when I was a kid, I played an arcade game where I would man a spacecraft landing on the surface of the moon, and you would need a certain minimum speed and rotation in order to safely land. The original game was called Lunar Lander, and it was in a lot of exploratoriums and science centers, which is probably where I played it too. I wanted to mimic the game's missions and dynamics and add a bit more interesting aspects to it. So I made Space Lander. This is proof of concept, where I take a simple concept and develop it as an interactive simulation or game to educate myself and others about the principal ideas, as well as flexing my coding muscles. The game I created is linked below, as is my GitHub for the project, and any of the references that I used to create the game. The concept of Space Lander is this. You man a rover that is slowly falling onto the surface of the moon. You must land on a flat part of the surface with low velocity and reasonably upright. You are challenged by the pull of gravity, delicate controls, and limited fuel to thrust your ship around. The concept really focuses on the delicacy of a landing, having to consider the ship's vector of travel and your limited ability to change velocity. My proof of concept includes two aspects. First, duplicating the original game, setting up the low graphics physics and sensitive maneuverability, determining when the lander has successfully landed or has not met the landing criteria. Second, expanding some concepts of the game, playing around with different obstacles, navigation requirements, and gravity fields. For the physics, gravity would be a big feature of the game, and I wanted more control over it than the built-in gravity. So I set the global gravity to 0 and used Area 2Ds to set up the gravity for each level. The lander, or the player body, is a character body 2D with simple button inputs. The whole cool thing about space is that if you don't do anything, you don't change velocity. Thrust is set up as an addition to velocity, since the lander needs to overcome the gravity and their own initial velocity to change their vector. At first, I set the rotation to just update the rotation of the lander, like the original game, but this was too easy. I set it up as a rotation velocity variable that updated the rotation every frame. If the lander thrusts left or right, then the velocity is changed. This made it much more interesting, as you could try to rotate left, only to quickly go too far and have to readjust. This is exactly what would happen in space, so mission accomplished. The landing pad is an Area 2D with a collision rectangle. Just like in the original game, the lander must be close to orthogonal to the pad and be under a maximum velocity when it lands. At first, I had set up the landing pad to read the speed of the lander, and if the velocity and rotation of the lander was okay when it entered that area, it would read as a good landing and the level would be completed. However, I noticed that if the lander is going very fast, then the pad doesn't have enough time to read the speed of the lander before the collision. So the lander hits the collision shape very fast, stops in its tracks, and the pad reads the velocity as 0. Turns out this is a common bug in games and software called tunneling, where an object goes so fast it creates a tunnel through the Area 2D and cannot be read. This is actually a pretty cool idea for a future level, reaching some minimum velocity to escape the gravity well or break through some surface. But for now, it was a bug, and my solution was to use continuous collision detection in Godot. I had revised the lander to use move and collide instead of move and slide, because this would give me the collision information for when the lander hits something. So if the lander collides with the landing pad, then the collision information is read for the velocity, and if it is under the requirements, then it's a good landing. Now I get the information at the time of collision rather than at the time that the frame loads it. This is fractions of a second of difference, but those fractions count, especially in space. The surfaces aren't anything too special. I generally created a line 2D of the outline of the surface, whether predetermined or randomized, and set the area's shape to collision polygon with the line 2D's points. It becomes a bit more complicated for each level, but pretty much when the lander hits the surface, an explosion animation plays, and it's game over. Animations were the last thing I added since I was very focused on the physics and gameplay, but it added a cool feel to it. I added emitters for when the thrusters are used and created some sprite frames to play when the lander crashed. The crash animation was interesting since I wanted to play a series of explosions around the location of the crash, then wait for the animation to be done until showing the game over scene. I could have and should have used a signal for this, but I had put all of it in the root script, so I just did an if-else statement. If not exploded, explode. If exploded, game over. I originally wasn't intending to export the game online, but I had learned that you could host the games on GitHub pages. I exported the game for web and took a bit of time to figure out how to get it to load onto the GitHub page. I had to do some stuff that I still don't really understand about the compatibility between Godot and the GitHub page environment. And at that point, it kind of worked. There were some issues with the HTML and CSS styling, so it was in the top left and overflowing of the game window, but eventually I got it to be centered and the window boundaries masked the rest of the page. The first level is the second level I worked on, just because I wanted an easier level before I introduced the topography. It's just a flat surface with the landing pad in the middle and some instructions about the labels. Level 1 is really my pride and joy, despite its seeming simplicity. The randomized topography was pretty easy after figuring out the best method of determining the next point. I pretty much chose the number of topo points I wanted, starting center left of the screen. Then added a point with a total screen divided by topo points number as x and a randomized y float. This ended up being way too jagged, so I set the y to be equal to the last y point plus a float. This was better, but I ended up creating a slope variable that existed through the iterations over the topo points and increased or decreased randomly. That way I could get some hills and valleys a bit smoother. After the topo was created, I added the landing pad at a random x location and set the y of the landing pad to be the y of an existing topo. Then I iterated back through the points of the topo around the landing pad in order to flatten them out. The real challenge was setting up the collision polygon to follow the topo, which was just a line 2D at this point. So if I just set the polygon shape to the topo points, then a collision would read when there supposedly wasn't a surface. It was then that I realized that the polygon has to be closed. The Area 2D needs a two-dimensional shape, not just a simple line. Truly a big brain moment for me. So essentially the collision shape was connecting the endpoints together, that being the center of the left screen and a random point on the Y screen. My fix for this was to add 2 points to the topo points array, bottom left and bottom right. That way it actually captured the space that would be the surface of the moon. Having the topo build out in front of the player took a bit of thought, pretty much just a timer, and told the topo script to create the points array, then add the points to the line when the timer timed out. Once it was done, the script set the collision shape and filled in black. I really like this visual. It feels like a deep space survey being built out in front of an astronaut. Once I had figured out the whole matching the line 2D with the collision polygon, the asteroid design was pretty easy. I created a gravity field and set the value to negative so that it pointed to the center. This was also where I had the idea of following pixels to show the gravity direction. I just created a particle emitter with a circle shape and set the angular acceleration to negative. I thought about creating a randomized surface for the asteroids like I did for level 1, but I thought that the angular math involved would be a bit more than I could chew right now, so I set it aside as a feature for the future. I really like the idea of manipulating your orbital speed to trick shot between celestial bodies. It comes up in nearly every sci-fi story, slingshotting yourself around a sun to meet a fast enough velocity. The close proximity of the asteroids made this very challenging, and the strategy seemed actually to just carefully skirt within one gravitational field and hopping to the other. But the overlapping fields made it pretty interesting. Level 4 is a pretty simple one, but an interesting challenge for the landing, and kind of a reminder that gravity doesn't always apply in some instances. If there is no gravity, you have to give yourself some velocity and then spin around before hitting the landing pad. I had thought about adding a downward thrust feature, but it would have made the game a bit too easy, especially for this level. Level 5 was a fun one to practice randomly spawned obstacles. Both the speed and elevation of the meteors was randomized. It just took a little bit of playtesting to find a challenging but fair speed. I'm also glad I didn't add the downward thrust here, because it makes it much harder to dodge them if you can only go up, or have to bravely nosedive down and pray you spin around in time. Many software engineers I know say that most of their job is in coding. It's about structuring their code to work together, to be organized, and to meet the project scope. I jumped into this project trying to figure out how to solve the problems of movement, landing, and spawning without a full idea about how these would communicate with each other and where the code should be placed in reference to the rest of the project. For example, a best practice for node structure in Godot is to not have nodes send information to their sisters directly. Rather, they should use their parent nodes to handle these communications. At the start, I had the lander communicate the speed and rotation to their sister node, the labels. If there was a level that didn't include labels, then the lander wouldn't have worked either. Instead, I changed the lander to send its information to a function in the root node that then updates the labels. I learned about global scripts a bit too late into the project. This is pretty much a script that loads into every scene when it's run, which is great for global variables and functions you would use in every level. I used this for the player color, which was a pretty late feature that my girlfriend demanded I included, because that is a variable that will stay consistent throughout each scene. This is the first time I actually used Git in a meaningful way. Since I was working on my own, I didn't see much utility in using different branches from my project, but I tried it with fixing bugs or adding features before merging it back into the main. I think I would have liked to have had a better perspective on how often I should commit and how to really structure my messages, and how to structure my Git in a more concise way overall. There were numerous times I made some catastrophic change and didn't know what happened, so I just reverted my local repo back to my last commit, which was extremely helpful. As a space nerd and the creator of this game, I took the concept and controls as very intuitive and straightforward. This was not the case. My girlfriend was my main playtester, and although she played games before, this required a bit more precision than she was used to. Sensitivity was a big challenge for her, so I adjusted the rotational thrusters so she wouldn't spin out of control so quickly. I also noticed that she held down the thrust a lot longer than I usually did, which was actually a great insight. Real spaceships don't tap the thrusters on or off to get the right speed. They thrust for extended periods of time because the thrust often needs a long time to counteract their existing velocity or the gravity they're dealing with. I finished this project in about 2 weeks, working a little bit every day on it. Looking back, I just jumped in and started building the game before having a full picture of what I wanted. I knew I wanted a game just like the arcade game, so I was really focused on the physics and the landing mechanics. I looked down my nose at stuff like UI or visual feedback, but those are really important for creating a fun and clear game. The game over screen, completion screen, and press up to start were stuff that I had seen would be helpful during the playtest. Also, adding the thruster visuals and sound as well as the explosion during the crash helped make it feel a bit more interactive, or a clear understanding of what was going on. I don't regret how I did this, because I just needed to follow my momentum to get started. and then force myself through the other stuff because by the time I lost steam, it felt like a sunk cost. Not a great disciplined mindset, but it worked. This was my first proof of concept and game that I had developed, and I feel like I learned a lot in terms of organization, user experience, game development, as well as some software, given that Godot script is very similar to Python. Thank you for watching, and please play my game linked below and tell me what you think. That's all for now. See ya!